let's go ahead and set this up. I've got 4 moles of copper. Moles of copper is up here, so I need to have moles of copper down here. So for every 1 mole of copper, and I'm getting this number 1 right here from this balanced chemical formula, for every 1 mole of copper, there are 2 moles of silver. I can't relate moles to grams without first going through what we call the molar ratio, right? 1:2 ratio. Moles of silver is up here, so moles of silver has to be down here. Now go back to your knowledge of the moles. Where am I going to find out moles to grams of silver? Periodic table, right? So I go to my periodic table, I look up silver, and I find out its molar mass. So for every 1 mole of silver, there is 107.87 grams of silver, and I got that right from the mass from the periodic table. Go ahead, it's going to be this number times this number divided by this number times this number divided by this number, right? These are ones, so we can just say 4 times 2 times 107.87 is going to give us in our calculators 862.96, and that's going to be grams of silver. Now, if I want to be really picky, because of sig figs, this only has 1 sig fig, so I really would want my answer to have only 1 sig fig. So you probably want to have an answer of 900 grams, okay? So if you're being picky about sig figs, which you know I am, you want your answer to say 900. Here's another similar example. We've got iron mixing with chlorine to yield iron chloride. So 30 moles of chlorine gas reacts. How many grams of iron chloride are produced? This is what I know. I got 30 moles of chlorine. This is my unknown. So go ahead and fill it in. I've got 30 moles of chlorine gas. And I want to know how many grams of iron chloride. So I've got 3 moles for every 2 moles of iron chloride, Cl2, sorry, and I want to write chlorine down here. And now I want to go from moles to grams, so I got to go to my periodic table, I look it up, I find out that iron chloride weighs 162.2 grams for every 1 mole of iron chloride. I got that from saying I have 3 atoms of chlorine added to 1 atom of iron, so that's 55, plus 3 times 45, which gives me the 162.2 grams. Go through and do the math. You've got 30 divided by 3 times 2 times 162 divided by 1 is going to give me an answer of, I'm sorry, it doesn't exactly fit on here, 3,240 grams of iron chloride. Check my sig figs. I've got 1, 2, 3 sig figs over here. I should end up with 3 sig figs over here. Don't worry about these sig figs. Don't worry about these sig figs. The only thing that's going to matter in the way of sig figs is what your problem started with. So the fact that your problem started with 3 sig figs means you're going to end here with 3 sig figs, and that 0 doesn't count as far as sig figs. Here's a problem that doesn't have the word mole in it at all. I want to know how many grams of silver, this is what I don't know, grams of silver, will be formed from 12 grams of copper. So the word moles is never mentioned. However, like we've said before, all roads lead through the mole. So this is what I know. I know I have 12 grams of copper. And for every 63.55 grams of copper, I got that from the periodic table, it will weigh 1 mole. Okay, so this number right here, this came from the periodic table. I had to get it into 1 mole of copper. Now don't forget, before you used to just be able to write 1 mole, but now you need to make sure you write moles of copper. Why? So that you can have moles of copper down here. And we're going to get 1 mole of copper for every 2 moles of silver. These numbers right here, these are the coefficient ratios, the mole ratios, and they come from the balanced chemical formula. Now we're in moles of silver. Now I just need to say that for every 1 mole of silver, it has a mass of 107.87 grams. Again, that's from the periodic table. So grams of copper cancels, moles of copper cancels, moles of silver cancels, and I'm left in grams of silver. So my answer is simply the top all multiplied together, divided by the bottom. Okay, you can type it in any order you want as long as you hit the divide by button every single time before the bottom. And you should get an answer of 40.7 grams. 3 sig figs, 40.7 grams of silver. Almost done. This problem has to do with methane reacting with oxygen to produce CO2 and water. This is a combustion reaction. It wants to know how many grams of oxygen are needed to react with 60 grams of methane. So go ahead and look at that chart on the back of your periodic table. If we go from grams to grams, you need to make sure you go through the mole first. Okay, all roads lead through the mole. Start with what I know. I have 60 grams of methane. In order to get from grams of methane into moles of methane, I need to look on my periodic table. So I've got 1 carbon, 4 hydrogen, which will give me a mass of 16.05 grams per 1 mole. And that's of CH4. I'm now in moles of CH4, so for every 1 mole of CH4, got this from the molar ratio, this 1 is because of this imaginary 1 mole of CH4, there are 2 moles of oxygen gas. I'd be done if the question was asking for moles of oxygen gas, but it's not, so I need to convert this. For every 1 mole of O2, there are 32 grams of O2, and that comes right from the periodic table. So you get the top, multiply, 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 divide, 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 and you should end up with a number that I don't actually have calculated. Hold on. $239.25. Want to make sure I keep only 3 sig figs. 239 grams of O2 should be my answer. You can go back and check to make sure everything canceled. Grams of CH4, I should have written that down there. Cancels with grams of CH4, moles of CH4, moles of oxygen cancel, and I'm left with grams of oxygen, and that's exactly what my answer is going to be in. Now, don't forget one last thing that you learned. For every 1 mole of a gas, there is 22.4 liters of that gas. And don't forget, this is at standard temperature and pressure. We're not always going to be at STP, so make sure you understand that today it's at STP, but tomorrow it might not. STP again stands for standard temperature and pressure. So here's a problem with potassium chlorate forming potassium chloride and oxygen. It says how many grams of potassium chlorate are required to produce 9 liters of O2, and this is saying at STP. If it doesn't say that in the problem, you can just assume that I mean at STP. So start with what you know. You know 9 liters of O2, and think about where you need to go. You're going to go from liters to grams. All roads lead through the mole. So in order to get from liters to grams, we have to first convert it into moles. So we know that every single gas, 22.4 liters of any gas, are going to equal 1 mole. And that's pretty convenient because now I'm in 1 mole of O2. So I can say, well, for every 3 moles of O2, this right here, this guy is my molar ratio, the most important thing in the whole problem. For every 3 moles of O2, there are going to be 2 moles of KClO3. So 2 moles of KClO3. The last step is to convert that back into grams of KClO3. Using my periodic table, I know that for every 1 mole of KClO3, there are 122.55 grams of KClO3. Add that up or multiply. 9 times 1 times 2 divided by 22.4 divided by 3 times this divided by this. And you're going to get a final answer of 32.8 grams. I'm sorry that that doesn't fit on there. And this is KClO3. I've got 3 sig figs here, 1, 2, 3 sig figs, and that's because I started with 3 sig figs here. Don't worry about the fact that you had 5 sig figs here, or some people like to pretend that these count. Nothing counts except for what you start with. Last problem of the day, how many liters of CO2 can be made when 48.0 grams of O2 react? So we always start with what we know, and in this case we have 48.0 grams of O2. I've got to get from grams to liters. It doesn't matter if I'm getting from grams to liters, grams, moles, whatever. I got to get into a mole. I know that there are 32 grams of O2. This is from the periodic table for every 1 mole of O2. That's called the molar mass. Looking up here at my balanced chemical formula, I can see that for every 3 moles of O2, there are going to be 1 moles of CO2. And this one here is from this imaginary one here. So grams cancel, moles cancels. Now I'm in moles of CO2. I can say that for every 1 mole of CO2, there are 22.4 liters of CO2, and that's for any gas. Go ahead, add those together, or multiply them. You get 48 divided by 32 divided by 3 times 22.4, which gives you a final answer of 11.2 liters of CO2. And that's it. We're all done. I know it probably was more painful for you to listen to, but now you can go ahead and get started on some practice problems.